Okay, let's talk gears. Gears are all over the place. They're in cars, they're in clocks, they're in transmissions, they're in bikes. They're all over the place. We need to know how to calculate gear ratio because that's really important. So here's a simple picture of a gear train. So gears are meshed together. That means their teeth are interlocking. So in this case, we have a 30 gear tooth, a 15 gear tooth, or excuse me, a 30 tooth gear, a 15 tooth gear, and a 60 tooth gear. And we always have to be told which one is the input or the driver. This happens to be our 30 tooth gear. And if it is spinning to the right, we call that clockwise. That's super important. Clockwise, then think about it, that's going to make the second gear spin counterclockwise, CCW, and then the third one is going to spin clockwise. This middle one, this center gear is called an idler gear. Its only purpose is to make gears spin the same direction or different direction. And what I mean by different direction, if we had 4 gears, I don't know, something like that, those 2 gears in the middle are idler gears, and in that case, it would make this one, if this one was spinning this way, it would make the output gear spin the opposite way. Okay, so we know that stuff. And let's move on a little bit. Gear ratio. Gear ratio is input to output, and it's always something to 1. It could be 2 to 1, like I wrote. We can use the little colon, or we can use like a fraction 2 to 1. It could also be 0.54 to 1. It's always to 1. So input to output. For every 2 times the input spins, the output will spin once. Okay, we'll come back to that. Here's our equation. Super simple. Gear ratio over 1 is equal to N stands for number of teeth, D stands for diameter, T stands for torque. The units for torque are usually foot-pounds. W stands for speed, and the units are RPMs, revolutions per minute, or rotations per minute, RPMs. And the way this works, you would be given a problem that would look a lot like this. And let's see what this says. The smaller gear that's 5 inches diameter, that's my driver. And the larger one is 10 inches. That larger one also has 60 teeth. And look what they're asking us. They're asking how many teeth does, let's pretend we're trying to find how many teeth this smaller 5-inch gear has. So I'm given teeth, I'm given both diameters, and I'm pretty well set. So let's pick number of teeth first. That's naut over nin. So it's going to be naut over nin equals, what else did they give me? Oh, they gave me diameter. That's daut over din. So then we can substitute my number of teeth on my output gear, that's 60, over my number of teeth on my input gear, that's what I don't know, equals diameter output, that's 10, over 5 diameter of my input. So 10 over 5. From here, we just cross multiply. 10 times nin is 10 nin equals, and then 60 times 5, of course, is 300. And then we divide both sides by 10, divide by 10, divide by 10. I'm running out of room. And 300, of course, divided by 10 is 30. Nin equals 30. So that's pretty much how all of them are.